Yeah. Some of you logged off. Okay. Let's continue. Yeah. So yes, let me take, is there any question from the class? If you have any question, you can raise your hand at the lower right bottom. Let me answer it for you. If there's any question, you can raise your hand. Okay. If not, let's continue. So there are two main types. Now we are on empty set, okay? An empty set is a set with no element, okay? And there are two ways of representing the empty set. The first way is using this, and then the second way is using the empty curly brackets, okay, to denote it. So empty set can be denoted using this one that looks like a zero cross out. And then we have what? The curly brackets, okay, with no element. Okay, then we have the sets of numbers. Okay, so I want you to take note of it briefly. So study it briefly before we continue. Okay, so clearly we can see positive integers start from 1, okay? But the set of integers, it's down here. So the set of integers start from negative infinity, okay, to positive infinity, okay? 0 inclusive, okay? Good. Then clearly you can also see that the set of natural numbers is equivalent to the set of positive integers, okay? But when we talk about real numbers, we are talking about all whole and irrational what? Rational and irrational numbers, okay? And that gives us a set of real numbers. Okay. Then, yeah, we have some examples here. So activity 1, we are told to identify each of the following as true or false. So just take a minute to solve it, and then you give me the answers. Activity 1.1. Yeah, can I have answers? So Adams, question 1A. I'm unmuting Adams. Question 1A, Adams.
Hello, sir.
Yes, your answer. Question 1A.
Yeah, I said A.
Is what?
True.
Yes, it's true. Correct. Okay. Now let's go to question. I think question one are quite easy. So let's go to question 2B. Question 2B, right?
Sir, question 2B.
Yes, 2B. True or false?
Sir, false.
Yes, you're right. Okay. Question 2E. Question 2E. Edna. Question 2E. Edna. Edna, we are not hearing you.
That's false.
It's false? Okay. So the question is, we have to ask ourselves, is -8 first a real number? Because A is a set of element X where X are real numbers. So is -8 a real number?
No, sir.
Oh, Adna, real numbers.
So real numbers are supposed to be positive, right?
No, real numbers are all whole numbers, rational numbers, and irrational numbers.
Oh, okay.
Uh-huh.
Okay, that's true.
So -8 is a real number.
It's true, sir.
Yes, so the answer is
okay.
true. Okay, good, Edna.
Okay.
Then F, question 2F. I have IB here. IB, I've unmuted you.
It's false.
It's false. Okay.
Yes.
Yes. So 3.4 is a real number, right? And is it less?
No, wait, sorry.
3.4 is a real number.
No, it's not a real number.
It is.
You said real numbers are all numbers.
Whole numbers, rational numbers, irrational numbers.
Oh. Okay, yes, sir.
Real number line. You've all forgotten about the real number line, eh? Okay. So 3.4 is a real number. Okay. And it's less than 6. So the answer is false. Okay. Because it should be a member of the set A. Okay. Now let's move on to the next question. So you try question 3B for me. Question 3B. This time you are listing the elements in the set. And I'll be taking the answer from Joseph James Nwako. James, I've unmuted you. Yes, Adams.
Oh, the element
Yes.
1, 4, and 9.
What? Come again.
1, 4, and 9.
1, 4, and 9. Okay, let me have more answers. More answers. Joseph has not answered though. Ima. Yes. Okay. Edna is up.
So 149.
149. Okay, so your answer is consistent with the first one. Okay, let's have
Yes.
another view. Another answer. Another answer. By calling your names, I'm marking you for participation. So Joseph, I'm still waiting for your response. Okay, maybe he's having a challenge with, no problem. So let me take Ginga Nathan. Nathan Giga. Nathan Jinga. Nathan, your answer. Okay, anybody with a different answer, you can raise your hand. Yeah, Ima. Emmanuel.
So
Yeah.
I'm getting 1, 4, and 9. Same thing.
1, 4, and 9.
Yeah.
Okay, let's do the analysis and see. So from the explanation, okay, here we are told we have a set X. The set is what? X, such that X belongs to what? Belongs to what? The set of what? Integers. Don't forget, integers start from negative infinity to what? Positive infinity. I told you to have a good look at the table before we proceed. So integers start from negative infinity to positive infinity. And we've also been told that x squared should be less than 12. Now let's see. Per the description you've just given me, if I square 1, when I square 1, I'm going to get 1. Also, if you are telling me x is 1, 4, and 9, then this last condition should be satisfied. So if I square 1, I get 1. If I square 4, I'll get 16. 16 is not less than 12. And then when I square 9, 9 is 81. It is also not less than what? 12. So these are wrong. Okay, good. I'm sure you are rather using the squares in place of the elements. In the position of the element, we are saying x. This time it's not x squared. It is rather x, so that the x are the what? The integers. Okay, good. So will you want to come back again, or I should solve it? Edna, do you want to come back? Okay, I'm not seeing any hand up.
Okay.
Yes, Edna.
So that means it'll be 1, 2, and 3.
Yes. So that's a better attempt. So we are talking about 1, 2, and 3. Because 1, 2, and 3 are the integers, right? They are the integers. and according to this description, the integers themselves are what? The elements in the set. But per this last condition here, our answer is limited because integers far from negative infinity. It means that if we are to use -1 square, -1 square is also an integer and it will be less than 12, so it's also part. The same way -2 square is also an integer. Okay, -2 is an integer, the square is 4, which is less than 12. -3 square is also an integer. -3 is an integer and the square is 9, which is less than 12. And the same way, 0 is also an integer. And 0 square is 0, which is also less than what? 12. Okay, so which means that the set contains the elements -3, -2, -1, 0, 1, 2, and 3. Good. So these are the elements in the given notation, set builder notation, or in the given set property. Okay, good. So that will give us these elements we have here. Start from -3 to +3. I hope that is clear enough. Good. Yeah, Rotimi.
Yes, sir.
Yes. You had your hand up.
Sir, I have a question, sir.
Yes, go ahead.
Yes, sir. The element, when we are to list, do we always have to start from the negative to the positive, or are there situations where the positive is like only required, sir?
Your question has to do with the type of the sets, okay? So if the sets we are talking about, let me go back to that table. It looks like a lot of you didn't take note of it. So these are the sets. If the set is a natural number automatically starts from +1.
Okay, sir.
If we are told a positive integers also start from +1. But if you are told the set belongs to integers, we have negative whole numbers, positive whole numbers, and 0 in the set of integers. Okay, so it depends on the kind of set given. I hope you understand.
Yes, sir. Yes, sir. Yes, I get it now, sir.
Very well. Okay, if there is any question, you can raise your hand. If there is any other question, you can raise your hand. Okay. If there is any other question, try and raise your hand. Let me address before we proceed. Okay. Yeah, so with that understanding, we are moving on to the next subject, which is the concept of Venn diagrams. Venn diagrams are very useful tools for analyzing what operations on sets, okay? And we've all seen them before, so we'll not spend so much time. We'll touch on the key relevant point. The first thing is, we all know that the universal sets, sometimes we use U, but in this context, we have E. So the universal sets is the set that contains all the entire elements, okay? The entire set, or let's say the mother set, and represented using a rectangle. Whilst other sets, smaller sets, are represented using what? Circles. Okay, so let's see the operations on Venn diagrams, so using Venn diagrams. In Venn diagrams, we have what we refer to as subsets, okay? And when we say a subset is a set which is smaller or is contained in another set. So given the set A and B, where A is contained in B, okay, we say that you can represent that as what? A here and then B up there. So for example, if you have a set A as what? The set A as 1 and 2, okay, and then the set B as 1, 2, 3, and what? And 4. Then that can be represented. We have 1, 2, 3, 4. It means that the elements in the set A are also contained in what? The bigger set, which is what? Of B. Okay, so we write A is what? Is contained in what? In B. Okay, very well. Now, there are conditions where the set A, so let me clear this first. There are conditions where the set A can be equal to itself, can be equal to B. Okay, so let's say we have A is a set 1, 2, 3. And then B is also the set, B also has a set 1, okay, 2, 3. If we are plotting this on the Venn diagram, okay, both A and B have 1, 2, 3. So you can say that A is in B, okay, or A is smaller than B. Okay, A is actually equal to the set what? B. Okay, but for the very fact that you see the definition of subset means the elements in the set should be contained in the other set. Okay, so the very fact that A is contained in B, we can still write what? A is contained in B, but equal to what? B. Okay, so here we just say that A is a subset. Okay, subset means it's contained in B. But in the first case where A was smaller, so in the first case where A is just one, elements 1 and 2, okay, and then we could draw A inside of B. So this time A is rather inside of B. We say that A is a proper subset. Okay, so in that case, we write A is a proper subset of what? B. So here we don't just write subset, we say proper, a proper subset. A proper subset. Okay. So that's the difference between a subset and a proper subset. A subset just means contained in. But a proper subset, it should be contained and smaller than the bigger set. Now, moving on, there is something we must know. That the empty set is a subset of any set. So if I give you any set, like set A is what? 1 and 2. an automatic subset of this set is what? The empty set. Okay, the empty set is just automatically a subset of any set. That is one thing you have to take note of. Good. Very well. Now let's move on to the next point. The next point is the power set of a set. The power set of any given set is the set of all subsets of that set. So if I have my set to be A, and I ask you to find the power set of the set A, then it is the set of all subsets of the set A. So for example, we have the set A as what? 1 and 2. What will be the possible subset of the set A? Okay, so we are looking at subsets. So for the subset of the set A, the first subset, which is the automatic subset, is what? Empty set. The second subset will be a set containing just one element, because that is smaller than the set A. Then the next set will be the set containing one element, which is what? 2. And then the last subset of A is the set which contains A but equal to A. Okay, so that is A itself. So then we can put all of these together as a set, because we are saying that the set of all subsets of a set A is what is called as the power set of the set what? A. Okay, so the power set is a set, but it is the set of all possible subsets of a given set. Very well. So let's try maybe another example. If I give you the set A as what? As 2, 4, and what? And 6. 2, 4, and 6 means we are going to have possible subsets will be what? The first automatic subset is now set. The next one will be 2. The next one will be what? 4. The next one will be what? 6. The next one will be 2 and 4. The next one will be what? 2 and 6. The next one will be 4 and what? And 6. And then the final one will be what? We have 2, 4, 2, 6. We have 4, 6. The last one will be what? 2, 4, and what? 2, 4, and 6. Okay. So these are all the possible subsets of the set A, okay, in the second example. So that is the power set of the set A. Good. Now, the question is, how sure am I that I've listed all the possible subsets? Okay, as a way of guide, okay, or as a guide, there is a formula which can be used to obtain the number of subset or the cardinality of the power sets of any given set. Okay, and that formula is given as what? 2 raised to the power n. So we are saying that the cardinality of a given set is equal to 2 raised to the power n. So the set, the first set we looked at contained 2 elements. A contained how many elements? N was what? 2. Okay. So if you're looking for the number of elements in that power set of A, it's going to be what? 2 raised to the power, 2 raised to the power what? 2 raised to the power 2, which is equal to what? 4. Okay, so it means 4 subsets in the power set. And indeed, it was true. We had the empty sets, we had the set 1 containing element 1, a set containing the element 2, and then the set containing the element 1 and 2. Okay, that makes it 4 subsets in the power sets of A. Okay, so the question is, then how many subsets elements will be in the power set of, let me say, if A is an empty set, then what will be the elements in the power set of A? Okay, so to be guided, we said you use this formula, okay, which is 2 raised to the power n. So if A is an empty set, then it means that the number of elements in the set will be what? Will be 0. So which implies that for the power set, we are going to have 2 raised to the power 0 elements. And 2 raised to the power 0 is what? Is 1. Okay, so we expect 1 element in the power set of the set A. And that 1 element is the automatic subset of every set, which is what? The empty set. Okay, so the empty set, like we said, is always the automatic subset of any set. So the power set of the set A is the set of an empty set. So you take good note of that. Okay. If you have questions, like I always say, raise your hand whilst we move along. Okay, I'll always be seeing your hand from up here. But if you don't raise your hand, it will be difficult for me to know if you do not get it. And again, unmuting the whole class, we're going to have so much feedback, which will disrupt our class. Okay. So let's move on. Yeah, there are some activities here on the slide. I'm sure you've seen them. I posted it to you before. Okay, Adams.
Yeah, I have a question.
Yes, go ahead.
Let's say you have a set A which contains elements.
Can you speak up a bit?
Right.
Adams, can you speak up a bit?
Let's say you have a set A
Mhm.
which contains elements 1 and 2, and maybe you have the number of elements in the set. Are you
Yes.
going to say 2 or 3 since empty set is also part of it? Which subset?
So the set itself contains 1 and 2. So there are 2 elements in the set, not so.
Okay. And maybe
So your n
the
is
number.
2. Let's take it step by step. So your n is 2, right?
Yes.
So the number of elements in the power set will be 2 raised to the power 2, which is 4. Do you get it?
Yes,
So the number of elements in the power sets of that your set is equal to 4. So this is only a guide to tell you that there will be 4 elements in the power set. Now let's list the elements in the power sets. The elements in the power set, like we said, you see your original set is just 1 and 2. It's 1 and 2. So when you are listing it, the power set only contains subsets, okay? And the empty set is a subset of every set. So this set A, one of the subsets of A is the empty set. Then another subset of this A will be just a set containing just one of the elements. So that will be the set 1. Then the next set will be what? The set containing just one element, which will be the set 2. Okay. Then the final element will be what? The final subset will be the set containing what? 1 and what? 1 and 2. Okay. In other words, when we use the Venn diagram, what we are saying is, if A is the set 1, 2, okay, then a subset of A will be, if I draw another set within A like this, it's a subset of the set A, right? The same way, if I draw a small set containing just 1, it's also a subset of the set A. And then if I draw the set A itself, it is also contained in A, so it's a subset of A. But what we should also know is that the empty set is automatically a subset of any given set, so it's always there. Okay, so these 4 elements or these 4 subsets will account for the 4 which we calculated earlier. Adams, I hope I've addressed your question for you.
Okay.
Good. Okay. If there's any other question, you can raise your hand whilst we move on. Yeah. Yeah, so quickly we want to move on to the next concept, try to wrap up. I have another class right after here. Yeah, so we have operations on set to union. Union just means you are adding up unique words, elements in the 2 sets, okay? Whereas the intersection are denoted with this notation, okay? I know we know these things. That's why I'm not spending my time. Intersection also means end. It means the common unique elements among the 2 sets. So I'll take an example on that. If I have the sets A as what? As 1 and 2. And then I have the set B as what? B as 1, 2, 3, and maybe 4. And then I ask for A union B. Like we said, it is a combination, adding the common unique elements, okay? So that's 1, 2, 3, and what? And 4. Okay, this is quite simple. Then A intersection B will be what? Will be common elements. So 1, what? 2. Okay, these are common to both sets. Okay, good. Let's move on. Then the next operation we have is what we refer to as a set difference. Okay, so the set difference just means less, less. Okay, so and the notation is using the minus, just like the minus implies. Less means just deduct one from the other. So